Just a couple of years ago, it seemed that space mining was inevitable. Analysts, tech visionaries, and even renowned astrophysicist Neil deGrasse Tyson predicted that space mining was going to be big business.
The first trillionaire there will ever be is the person who exploits the natural resources on asteroids.
In a 2017 note to investors, a Goldman Sachs analyst wrote, "Space mining could be more realistic than perceived. A single asteroid the size of a football field could contain $25 billion to $50 billion worth of platinum." Space mining companies like Planetary Resources and Deep Space Industries, backed by the likes of Google's Larry Page and Eric Schmidt, cropped up to take advantage of the predicted payoff. After all, the holy grail of asteroids, known as 16 Psyche, had an estimated worth of 10,000 quadrillion dollars. But fast forward to 2022, and both Planetary Resources and Deep Space Industries have been acquired by companies that have nothing to do with space mining. And humanity has yet to commercially mine even a single asteroid. But that hasn't stopped a new crop of startups from trying.
AstroForge's mission, obviously, is to leave Earth with a vehicle, go out to an asteroid, mine it for its rare earth elements, and then return that to Earth to be sold.
TransAstra was founded with the mission of working towards the vision of harnessing the resources of space, especially the asteroids, for the betterment of humanity. There's enough material in the asteroids to support a population of 1 trillion people.
So far, the closest we've gotten to mining an asteroid has been prospecting missions. In October 2020, NASA collected a small dust sample from the asteroid Bennu as part of its OSIRIS-REx mission. The sample is not due to return until 2023, but during the mission, scientists were surprised to learn that Bennu's surface was not as solid as predicted. In December of 2020, Japan's Aerospace Exploration Agency brought back a sample of an asteroid known as Ryugu as part of its Hayabusa 2 mission. To collect the sample, the agency fired a projectile at the asteroid and scooped up the flying material. Like Bennu, scientists found that Ryugu also had a rubble pile surface. Although these recent advancements by the likes of NASA and JAXA have provided useful information on the composition of asteroids, space mining has yet to become a commercial endeavor. So what's taking so long? For one, space mining is a long-term endeavor, and one that VCs did not necessarily have the patience to support.
If we had to develop a full-scale asteroid mining vehicle today, we would need a few $100 million to do that using commercial processes. It would be difficult to convince the investment community that that's the right thing to do.
Take NASA's OSIRIS-REx mission, for example, which is expected to take 7 years to complete and cost over $1 billion, all to bring back a handful of asteroid material. And Planetary Resources? Despite its millions in investment, the closest the company ever got to asteroid mining was launching a satellite to prospect future targets. In fact, the mining of celestial objects has become a point of satire, showcasing corporate greed, as seen in this clip from Netflix's 2021 film, Don't Look Up.
This comet hurtling towards us from deep space actually contains at least $32 trillion of these critical materials, critical to technology.
I'm sorry, is that why you aborted this entire mission? Is because you're trying to mine the comet
Dr.
for
Mindy,
rare
I
minerals?
think we should hold off.
Others say mining precious metals to sell on Earth never made much economic sense.
If you look at platinum, the production cost, platinum is around $1,100, even more. And the price per ounce, platinum is less than $1,000. So it means the earth mining is not profitable right now. When analysts made their predictions, they were looking at the amount of the precious metals and materials in the asteroids, and they didn't look at the economies of the industries.
In today's economics, and in the economics of the near future, the next few years, it makes no sense to go after precious metals and asteroids. And the reason is the cost of getting to and from the asteroids is so high that it vastly outstrips the value of anything that you'd harness from the asteroids.
When we think of space mining, precious metals likely come to mind. But in fact, asteroids can contain other materials, which, in the short term, could be even more viable.
There is mining materials in space for use in space. And then there is return to Earth.
The return to Earth ideas, they have to compete against terrestrial markets for those same materials. That would be very challenging, and it may happen someday, but it's most likely in the far future. But in the near term is mining materials for use in space. The number one item is water. There are certain types of asteroids that have hydrated minerals. We can process those minerals to release the water. Our best use of the water is actually as processing to make it into a rocket propellant. And then with rocket propellant, we can move around space more readily. We don't have to launch all of our propellant from Earth.
Gabor Psyche agrees that when it comes to mining the cosmos, we should look beyond precious metals.
In short term, we should focus on helium and water. Helium because it's not readily available on Earth, and water because it has a potential use in space.
An attorney by trade, Psyche spent several years working with the European Space Agency and decided to focus his legal expertise on advising space startups. He's now an advisor for an Australian startup that aims to mine water and helium-3 from the moon. An isotope of helium, helium-3 has applications in national security, medicine, and cryogenics. Recent helium shortages have forced some research labs to suspend their projects and induced national security concerns. Knowing what we can mine is one thing, but figuring out how to mine it is another. Braced with new data from NASA and JAXA, scientists and companies have had to devise new ways to mine asteroids.
In older thinking, landing on asteroids and anchoring to them and drilling or excavating were the scheme. That may now look less viable because of what we've learned of asteroids.
Scientists typically categorize asteroids by their composition type. C-type or carbonaceous asteroids are most common and are made up of clay and silicate rocks and contain water. S-type or stony asteroids are the second most common and are generally made up of a metallic nickel-iron and magnesium silicate mixture. Finally, M-type or metallic asteroids account for the rest of the known asteroids and are thought to be primarily made of nickel-iron.
What we've learned is that most asteroids are rubble piles, as opposed to one big mountain-sized solid piece of material.
Based on this new understanding of asteroids, TransAstra has been working with Dreyer to develop a technology it calls optical mining.
The optical mining process that we've invented involves step one, capturing the asteroid in an enclosure, what we call a capture bag. The asteroids are typically spinning, because that's what they do in space. Our spacecraft matches the spin with the asteroid, flies the bag over the asteroid, captures it, and cinches it down tight so we have positive control. Now, once we contain the asteroid in our capture bag, then our solar reflectors redirect that concentrated sunlight into the capture bag, and we use it to drill holes in the asteroid and heat up the material and drive the volatiles, the water and the other gases, out of the minerals. And then we can capture those volatiles in an ice trap.
TransAstra is initially focusing on mining water to make rocket propellant, which Searles says will enable low-cost space travel. But eventually, the company plans to harvest everything on the periodic table.
We've calculated that a single TransAstra mining vehicle, one we call the Honeybee, can fly out to an asteroid and bring back about 100 tons of water and other ices in a single mission. It's worth about $1 billion. And we know that because we have a contract to deliver 100 tons of ice in geostationary orbit from a publicly traded company.
But that kind of revenue is still a ways off. TransAstra is funded by about $5 million in grants and contracts from NASA and several million in venture funds. To keep itself above board, Searles says that TransAstra is focusing on developing its intellectual property piecemeal, using the tech that will eventually be incorporated into its mining missions to satisfy already existing market needs.
One of the commercial opportunities is traffic management. With our Sutter telescope technology, we can turn a small, inexpensive commercial telescope into a powerful instrument that can see space traffic and orbital debris, something the size of a toaster oven, all the way out to the orbit of the moon.
TransAstra has already deployed its telescope system at 2 observatories in the US, with the technology currently being used for asteroid prospecting. Eventually, TransAstra also plans to launch its telescope tech into space to be able to see deeper into the universe.
Likewise, there's a burgeoning orbital logistics business today for delivering satellites to their orbital destinations from where rockets leave them off.
To do this, TransAstra is developing an orbit transfer vehicle known as Worker Bee. the body of which can also be used for its asteroid mining vehicle. But the company has yet to operate any of its technology in space. Still, Sercel says that TransAstra is already making a small amount of revenue from starter contracts for its satellite tugging services and has brought in more than $500,000 from its Sutter telescope tech in the form of NASA R&D grants.
Our plan is to be revenue positive at every step along the way while we're building the company and using these near-term businesses to mature the technology. And then as you do that, you have all the pieces in place to go out and start asteroid mining.
Our mining process is 3 stages. We have to do a vaporization of the material. So we're going to take an asteroid and essentially vaporize it into a cloud of atoms. And then we're going to ionize it. So we're going to each take that cloud and positively charge all the atoms. And then once we have a whole bunch of positively charged atoms, we can sort them.
AstroForge is another early-stage company trying to make space mining a reality. Founded in 2022 by a former SpaceX engineer and a former Virgin Galactic engineer, AstroForge still believes there's money to be made in mining asteroids for precious metals.
We have a limited amount of rare earth elements, specifically the platinum group metals. These are industrial metals that are used in everyday things, your cell phone, cancer drugs, catalytic converters, and we're running out of them. And the only way to access more of these is to go off-world.
AstroForge plans to mine and refine these materials in space and bring them back to Earth to sell.
The key technology that we're developing is our ore processing system. So that system consists of the excavation subsystem that moves the material from the asteroid into the spacecraft. And then there's that refinery piece that extracts the valuable material and removes all the unnecessary material that we can't actually sell on Earth.
To keep costs down, AstroForge will attach its refining payload to off-the-shelf satellites and launch those satellites on SpaceX rockets.
There's quite a few companies that make what is referred to as a satellite bus. This is what you would typically think of as a satellite, the kind of box with solar panels on it, a propulsion system being connected to it. So for us, we didn't want to reinvent the wheel there. The previous people before us, Planetary Resources and DSI, and they had to buy entire vehicles, they had to build much, much larger and much more expensive satellites, which required a huge injection of capital. And I think that was the ultimate downfall of both of those companies.
SpaceX really allowed a lot of companies to start in the aerospace world, basically because of the lowered cost to access space. So now we can kind of leverage that and really focus on just the technology piece.
AstroForge says it's raised $23 million in venture capital funding and plans to conduct several test missions before launching its first official mining mission in 2025. The company is targeting near-Earth asteroids, with a single mission expected to take around 2 years.
Our first mission is to send up a refinery. So we are going to take an artificial asteroid. We are exactly concentrations we've created, so we are going to show that we can extract platinum from this in zero-G in a vacuum. Mission number 2 for us is a prospecting mission. This is where we go out to an asteroid, we make sure we can get to an asteroid, our spacecraft can last for 2 years, and we can take high-resolution images of it to make sure the surface is what we expect it to be. The third mission, we now introduce our extraction arm to that mission. We're going to go out, we're going to take a sample of the asteroid, bring that back to Earth, and we'll study it on Earth to understand exactly what the concentrations are of that asteroid. Our fourth mission is where we put all those pieces together. We send out our mission with the excavation arm, we put our processing facility on it, and we repeat those steps in order to get platinum.
Like Planetary Resources and Deep Space Industries before them, today's asteroid mining companies face a large number of challenges. The first is uncertainty stemming from the lack of an established international law to govern space mining. At the moment, most space activities are governed by the Outer Space Treaty, which was established during the Cold War. One of the treaty's principles prohibits the appropriation by individual nations of any celestial bodies, such as the moon or asteroids, and requires that any space exploration and use should benefit the whole of humanity.
When it comes to space mining, the whole discussion is about whether Outer Space Treaty allows or bans space mining. One of the interpretations what we should do with the mined minerals is to share the benefit which is coming of it, and it's not clear whether the benefit should be the wealth which is emerging from mining the space mineral, or whether mining can provide us with some scientific knowledge, and the benefit would be just sharing the scientific knowledge.
In the absence of an established international law governing space mining, some countries have taken it upon themselves to establish their own. The Commercial Space Launch Competitiveness Act, passed by the Obama administration in 2015, raised eyebrows when it gave property rights to companies for the materials that they mine from asteroids, though it stops short of granting companies ownership of the asteroids themselves. In the time since, Luxembourg, Japan, and the United Arab Emirates have established their own space mining laws. But Schmidt says not having an international law for space mining could be enough to dissuade some companies from trying to mine the cosmos.
I think that the national laws are not enough for the companies to overcome the legal uncertainty they observe, especially when you ask about the ownership. If they invest money and go to space and mine something, and the discussion about the ownership is not clear, they don't have certainty that what they are going to mine will be theirs, and they will have full freedom to use the material for whatever they want.
But Sercel says there's already precedent for this.
There's limited slots in geostationary orbit where you can put satellites. Once you have the allocated slot and the satellite, other countries and other companies are not allowed to go there and mess with it. So we're certain that when we go to an asteroid, capture it in a bag, and mine the resources from it, that we will own those resources.
Another challenge is even more basic: deciding which asteroids to target for mining in the first place. Prior to conducting their own missions, all early-stage mining companies have to go on is existing observation data from researchers, and a hope that the asteroids they have selected contain the minerals they seek.
The most challenging aspect of asteroid mining is really the asteroid itself. We have a lot of evidence and observations and scientific data, but we don't actually have a lot of truth knowledge, meaning there's only been a handful of missions that have actually gone to the asteroid. So you can design a perfect system, you can control all of these things, the technology piece you can control, the operations piece you can control, but you can't control what the asteroid is until you get there.
If the companies do somehow manage to extract the materials they're seeking, the next hurdle is selling them. Theoretically, an influx of precious metals introduced to the commodity market on Earth could be enough to crash it. But AstroForge says this is unlikely.
When you look at the supply and demand curve for platinum group metals, right, the total market cap of these metals is measured right around $60 billion. We're talking about bringing back $80 million per mission. So for us, it would take quite a bit of missions to really greatly affect the supply and demand curve as we go forward.
For now, commercial space mining remains highly speculative, with companies just starting to test out their tech and business plans. Still, experts believe that some form of asteroid mining will eventually take place. The question is when.
I think we will be able to mine an asteroid within the next decade. At the very least, this will be done as a proof of concept for a mining process, but possibly also include an actual sale of most likely water to be then processed into propellant.
In terms of the timeline for mining asteroids, for us, the biggest issue is funding. So it depends on how fast we can scale the business into these other ventures and then get practical engineering experience operating systems that have all the components of an asteroid mining system. But we could be launching an asteroid mission in the 5 to 7 year time frame.
If we have a developed and working space manufacturing industry, then I can imagine asteroid mining will become a valuable option. But it's not a 10 years time period. I believe that we are going to mine in space, maybe 20, 25 years from now.